In today's video or topic that I will be going to discuss is all about the last topic of chapter 4, which is liquid surface condition number 2, no? So this one, I will be very specific to it that it is closed cylindrical or vessels which is more than half full of liquid rotated about its vertical axis, wherein height or the depth is greater than the half of total height. So the first condition, which is the height or the depth of paraboloid, or the half of it is the less than of the d. The d is the distance from the rim to the surface of the liquid. Okay, no? Of course, it is no. And in all this condition, there is no liquid spill because it is closed cylindrical. I mean closed vessel. So the second condition would be y over 2, or the half of the depth of paraboloid, is equals to the d, which is the top surface just touching the rim. Again, this is closed vessel. And the third condition would be 1/2 the y, or the depth of the paraboloid, which is greater than, and this one is less than, greater than of the d, the imaginary paraboloid above. No. And the fourth one would be y equals to h squared over 2d, the vortex just touching at the bottom. So there is also imaginary paraboloid, or the upper part of the paraboloid is imaginary. And lastly, the y is greater than the h squared over 2d, wherein the vortex is below at the bottom of the vessel, this one. So imaginary na po, imaginary sa ibabaw, imaginary sa ubos. Note that for closed vessel, there can never be any liquid spill. Again, so the initial volume of liquid before rotation is equal to the final volume of the liquid. So there is no liquid spill, no, as I have said. The volume of air relation is more convenient to use in solving this type of problem. So there is pressure involved. So the first example would be a closed cylindrical vessel 2 meters in diameter and 4 meters in height is filled with water to a depth of 3 meters and rotated about its own vertical axis at a constant angular speed omega. The air inside the vessel is under a pressure of 120 kilopascal. The first question, what angular speed omega when the water surface is just touching the top rim? Second, or B, if omega is equal to 12 rod per second, what is the pressure at the center and circumference at the bottom of the tongue? C, what angular speed will just zero the depth of water at the center? And D, if omega or angular speed is 20 rod per second, how much area at the bottom is uncovered? So A first, no, the solution is here. So it is said na angular speed, or it is asked what is angular speed, and we are instructed that the water surface is just touching the top rim. So the condition number 2, or second condition, is very applicable to the said problem or asked question. So itong illustration is this, no? So again, as I have observed in your redrawing, others are very kanang galisod og draw. If you are not good at freehanding, so use rulers so that your drawing illustration is more kanang likely to read or to see para di siya mautanawon. and it is indicated na 2 meters, so therefore our x is katunga sa 2 is 1. Again, this is the omega which is unknown. This one is x equals to 1 and it is closed. And 4 meters side is filled with water to a depth of 3. So capital H is 4 meters. This one is small h, which is 3 meters. And of course, this is t, which is 1 meter. So just touching the top rim. So this is 1. And here to top rim, or d, equals to y over 2. So y over 2 equals to d, which is 1 meter. And always remember that the formula for y, or the depth of paraboloid, again this is paraboloid and the bottom of it is the vortex. So omega squared x squared over 2g. So 1 times 2, the body is 1 and y over 2, so cross multiply the y, or this total of the depth of the paraboloid is 2 meters. So 2 equals to omega squared 1 squared over 2g times 9.81, and cross multiply. So 2 times 9.81 over 1 squared omega squared, so square root both sides, therefore our omega is 6.26 rad per second. So to convert to RPM, again, let's multiply this by 30 over pi. So our omega now is 59.78 RPM. So this is the answer for A. For B, we are asked the pressure at the center and the circumference at the bottom of the tank. Now given with omega 12 rad per second. So using this formula, omega squared x squared over 2g, 12 squared times 1 squared over 2 times 9.81. So therefore our y is 7.34 meters. And take note that there is called modified y. So why it is happening? So why it is happening? Because nasa condition, since B is vortex just touching at the bottom, so therefore we will be using this formula, y equals to h squared over 2d. At i-check lang nato if mag-guarantee ba ang kanina value. Y equals to h squared over 2d. So 4 squared over 2d times 1, and it is 8 meters. So our y here is 7.34 is less than to 8 meters. So therefore, we are going to use this, no, this value 7.34. So to illustrate, si patong illustrate. So touching here. So this one is y. So let's redraw again. This is close. So this is the front view. No. So this one here is the x. And here is the x sub 1. So the y here is the y sub 1. And so we have to consider this one. Since this one is, diba, as it is indicated na y over 2, no, I think we need this formula just to check if applicable ba ani. But it turns out na 8 is dapat supposed no na value sa y, but it is less than. So ang ato lang kanan is not touching the bottom. No, so therefore we can extend. So it is not actually touching the bottom. So nalantay pa nung dari. This is the h sub 1. Because this is the total edge, capital H. And this one is the small h. So therefore, atong y sub 1 is here to here ra. And our h sub 2 na capital is from bottom to the atong imaginary paraboloid. Or let's say it is small h, no? As you can see h equals to y sub 1 plus h sub 1. And remember that the pressure at center at the bottom, which is P sub center, equals to unit weight times h sub 1 plus 120 kilopascal. No given man, the air inside the vessel is under pressure of 120 kilopascal. So from ganina no tong equation na h sub 1 equals to h minus y sub 1. Using the squared property of parabola, wherein x squared over y, so the total, no, since this is y, so x over y and x sub 1 squared over y sub 1. So 1 squared over y is 7.34 equals to x sub 1 squared over y sub 1. So cross multiply. So our formula or the equation is x sub 1 squared equals to y sub 1 over 7.34. So this is the equation 1. Volume air relation of air relation, wherein V sub air initial equals to V sub air final, wherein pi x squared d, diba, equals to ang V air final is pi x sub 1 squared y sub 1 over 2, no, parabola. This is the parabola formula. This one is related with the volume of the cylindrical. So input the values, pi 1 squared tapos 1 equals 2 pi x sub 1 squared y sub 1 over 2. Again, para di malibog, ang atong parabola is pi, kani ba? So pi x sub 1 squared times y sub 1 over 2. And claro, this is 1. And cross multiply. If it turn out, cancel ang mga pi. So 2 equals to x sub 1 squared y sub 1. Therefore, our x sub 1 squared equals to y sub 1 2 over y sub 1. So this is the equation 2. So we must equate the two equations formed, 1 and 2. The first equation is y sub 1 over 7.34 equals to 2 over y sub 1. So cross multiply. So it is y times y is y sub 1 squared equals to 2 times 7.34, and squared both sides so that mawala ang squared. So y sub 1 equals to 3.83 meters. And going back from this equation, so our h sub 1 is h is 4 minus 3.83. Therefore, h sub 1 is 0.17 of a meter. Again, h sub 1 is this one. Vortex to the bottom of the container or the vessel. So therefore, the P center equals to 9.81 times 0.17 plus 120. Unit weight, since this is water, so specific weight is 1. And the H sub 1, no? So, muna dari, 9.21 times 0.17. So, the answer is 121.67 kilopascal. I mean, one way to get the answer, or one of the answers, ang kani. So, sa circumference pressure, so pressure at the circumference at the bottom, wherein P sub circum equals to unit weight times H sub 2 plus 120. No? H sub 2 naman ang pan. Because circumference, ang top rim. As you can see here, a y, di ba ang y? It is h sub 2 equals to y plus h sub 1. No? That is the equation we can form. We know y is 7.34 plus 0.17 ang h sub 1. So therefore, our h sub 2 is 7.51 meters. So our P sub circum or circumferential pressure or circumference pressure, or the pressure at the circumference at the bottom of the tongue, it is 9.81 times 7.51 plus 120, or the answer is 193.67 kilopascal. So that is B. And now C. The C is what angular speed will just zero the depth of water at the center. So once gani ang ani, deep the water. So let's try again this formula, no? Y equals to h squared over 2d. And we have already solved this, but I need to do it again. So 4 squared over 2 times 1, it is 8 meters. No? To illustrate, it would be like this. 4 meters here, therefore yan naman gi-indicate no, the problem said na what ang the speed will just exert the deep water. So, in touch is siya sa bottom sa container. So, kani, it is going to be used na value. So, this one is y equals to 8. Always remember na container is 4. So, therefore, 4, 4. So, 8 no. And using the formula now, y equals to omega squared x squared over 2g. We have the value for y. So, 8 equals to omega squared 1 squared over 2 times 9.21 cross multiply, so it will be omega squared 8 times 2 times 9.21 over 1 squared, so square at both sides, so therefore our omega is 12.53 rad per second, and we can answer, or it is necessary na ato siyang RPM. So, 30 over pi. So, our omega is 119.65 RPM. So, this is the answer for C. So, D. The D is given, no, ang omega, which is 20 rad per second. So, how much area at the bottom is uncovered? So, talking of bottom, so therefore, the fifth condition involved. So, we know na ang atong kwan. So, illustrate na nga ito ni. So remember that again. So this is the x. This one here is the x sub 1. And here, sa uncovered na, x sub 2 or sa imaginary no, bottom sa vessel. And it is expected na x sub 2 dari and kani is the y sub 1 because the total is the y no. So using the formula y equals to omega squared x squared over 2g. So our omega is 20, so squared it, and 1 squared over 2 times 9.21. So our y is 20.397 meter, no? It is very evident na greater siya. Di ba ang y is greater to x squared over 2d, which is 8. So it is greater sa 8 meters. So ang uncovered area, which is a sub uncovered, again it is closed. So it is pi x sub 1 squared, no? X sub 1 bob, it is said uncovered, so x sub 2. To be able to get values for y sub 2, x sub 2, so again, let's use the by squared property of parabola. X squared over y equals 2, x sub 1 squared over y sub 1, x sub 2 squared over y sub 2. And we all know that x is 1 squared over y is 20.39. So x sub 1 squared over y sub 1. So cross multiply, we arrive with the equation of x sub 1 squared equals 2 y sub 1 over 20.39. So this is the equation number 1. So coming from here, no, let's form another equation. So y1 squared over 20.39 equals 2 x sub 2 squared over y sub 2. Cross multiply, so x sub 2 squared equals 2 20.39 over y sub 2 squared. I mean y sub 2 lang. Mali ba? So bali, no? Dapat y sub 2 over 20.39. So this is the equation number 2. And volume of air relation, so if you are again this is always now V sub air initial equals to V sub air final because it is close as indicated or noted with the statement, or I have told you and said. So sa V initial pa ay 1 squared, tapos ang D is 1. Here also is pi x sub 1 squared y. Again, parabola, no? Over 2, minusan na to parabola kani as a whole and minusan ani, so this one. So pi x sub 2 squared times y sub 2 over 2. And this is 1. And we know that we can cancel the pi. So it turns out natong kuan and pwede na ni isahon. So 2 equals to x sub 1 squared y sub 1 minus x sub 2 squared times y sub 2. So this is the equation number 3. We can substitute the equation number 1 and numbers 1 and 2 in equation number 3. So sub equation 1 and 2 to 3. No, kani mga value ha. So 2 equals to equation 1 is y sub 1. Y sub 1 over 20.39 times y sub 1 minus y sub 2 over kani 20.39 times y sub 2. 2 equals to y sub 1 squared over 20.39 minus y sub 2 squared over 20.39, and isahon na ni, so it will become 40.78. So y sub 1 squared minus y sub 2 squared. Take note na y sub 1 is, diba, y sub 1 equals to h, capital na H, plus y sub 2. And h is 4. 4 plus y sub 2. So 40.78 equals to 4 plus y sub 2 squared minus y sub 2 squared. So 40.78 equals to 16, 8 y square, 8 y sub 2 plus y sub 2 squared minus y sub 2 squared. So cancel ang y sub 2 squared. Therefore 40.78 equals to 16 plus 8 y sub 2, and it will become so 8y sub 2, bali na to no, 40.78 minus 16, no? So y sub 2 equals to 40.78 minus 16 over 8. So therefore our y sub 2 is 3.10 meters. So our goal here is that to find the x sub 2 so that makaproceed na to sa area uncovered. And going back sa equation 2, no? From equation 2, so x sub 2 squared equals 2, y sub 2 man, so 3.10 over 20.39. Squared both sides so that mawala ang square root, square root both sides para mawala ang squared. X sub 2 equals to 0.39 of a meter. So going back here, so area sub uncovered area equals to pi times 0.39 squared. So the answer is 0.48 square meter. So this one. No, that's the second liquid surface condition. And I think we're ready for the third one, the liquid surface condition number 3. So there's only condition involved. For closed cylindrical containers completely filled with water, so diba kani is closed siya pero half filled, dili mo puno. Ang katong una na condition or liquid surface condition number 1 is open siya. So, the third one is medyo tricky. But I know we can do it. So, puno siya again ha. This is closed. Sorry for my illustration. So, the first one is without pressure at the top. So, walang pressure at the top, no? Just simply ningkon lang. Nalay deep ang paraboloid. The second condition is with pressure at the top. So, involved ng pressure. So, example ta para mag-gets. A 1.8 meter diameter closed cylinder, 2.7 meter high is completely 2.7 meter high. It's redundant. .7 high is completely filled with glycerin having specific gravity of 1.6 under a pressure of 245 or 245 kilopascal at the top. The steel plates which form the cylinder are 5 millimeters thick with an ultimate tensile stress of 82 megapascal. How fast can it be rotated about its vertical axis to the point of bursting? So, this one, ang kanina principle, muna yung nagamit sa mga gasol, ganang anything na close siya with kaya mo kan ang capacity niya is full storage balibang, no, kanina idea kanina principle. So as you can hear na naman siya pressure as well as napagani mga megapas tensile stress. So the second one atong gamiton. So ang drawing ani is that ang ani. So again, this is full. So the only thing we can do is draw na lang. So this one, and this is H equals to P over unit weight. And this is H sub 1, which is P over unit weight. And it is given no na the capital H is given man na 2.7 high. So capital H, which is 2.7 m. Again, this is glycerin. So our specific gravity is 1.6. So y equals to omega squared x squared over 2g. And since involved man ang ato ang tensile stress, so way back ta sa tensile stress is 10 volt pressure, wherein the tensile stress is S sub T equals to P sub 1D over 2T. And diba 82 megapascal, so before to arrive anino, we must get first the P sub 1. P sub 1, and since H sub 1, so P sub 1 ni makuha natin H sub 1, and H sub 1 di ba kani as a whole minus sa Y, so na si H, or atong balihon, h sub 1 minus h, so y. So our goal again is p sub 1. So tensile stress is 82. Since it is mega, tato siya 8 kilo by 10, I mean by 1,000 equals to p sub 1. So our d is so our d or diameter is 1.8. Tara. And again, it is here x is 0.9 katunga sa 1.8. So 1.8 over 2. So thickness is convert to 5 meters, convert 5 millimeters converted to uh, mali ata ni 1,000 millimeter 1 meter. So 0.005 meter. So 0.005, no? So cross multiply, therefore p sub 1 is 82 by 1,000 times 2 times 0.005 over 1.8. So our p sub 1 again, once you said pressure, so it is small p. So the answer of it is 455.56 kilopascal. So, 'di ba, h sub 1 na naman tayo p sub 1, so h sub 1 equals to p sub 1 over unit weight. Again, unit weight man, ang thinking that glycerin is involved, so gamito na to yung specific gravity. So ang pressure is 455.56 over 9.81 times 1.6. So h sub 1 equals to 29.02 meters. And our h is given ng pressure, which is diba ang pressure is 245 as a man. Tara, 245 kilopascal. So our h, p over unit weight, so 245 over 9.81 times 1.6. So our h is 15.61 meters. Again, no kanino? So h sub 1 equals to y, diba? H sub 1 as a whole is equivalent sa h kani dare h. So h sub 1 ay tara, h sub 1 equals to y plus h. So our y here is that h sub 1 minus h, no? H sub 1 is 29.02 minus h is 15.61, so y therefore is 10.71 meters. And take note na atong target is to get the angular speed. No? How fast can it be rotated? So, the angular speed. Using the formula, y equals to omega squared of times x squared over 2g. So, y is 10.71 equals to omega squared times our x is 0.9 squared over 2 times 9.21 cross multiply, therefore it is 10.71 times 2 times 9.21 over 0.9 squared. Square root both sides so that we can get rid of the squared. So our omega is 16.11 rad per second and convert to RPM, so 30 over pi. So our omega is 153.84 RPM. So this is the answer for D. I mean, example number 2. Under the liquid surface condition number 3. So what if we have this one? No? So it is the example number 3. We're in without pressure at the top. So a 1.5 meter diameter, again phi is diameter, closed cylinder 2.5 meters high is completely filled with oil. The cylinder is rotated. So it is rotated about its vertical axis at an angular speed of 85 RPM. Determine the height of imaginary parabolite above the vessel. So y at kita on solution. So this is closed, filled with oil. S equals to 0.8. This one is y. And the only thing we can do is the 0.1 would be ato sa indicate pod ang kani is 2.5 m given ang angular speed which is naka RPM, so we need the rad per second, 85 RPM, so pi over 30, and it is 8.90 rad per second. So y equals to omega squared x squared. So 1.5 man tunga sa 1.5 is 0.75. Ah, 0.75 squared over 2 times 9.21. So y is 2.27 meters. So this is the answer for example number 3. That showcase or show the condition, no, first condition without pressure at the top. So we've come an end to chapter 4, and luckily next video or the last topic or chapter for fluid mechanics, and as well as the sa midterm is chapter 5, which is fundamentals of fluid flow. So hope that you have learned something, and hoping more learnings from the videos that I have uploaded and introduced to you. So thank you for watching, and God bless. Goodbye.